It's a sheet that gives you the ability, or gives us the ability to evaluate the incremental value potential from modification to certain variables within the production process. I'm going to start out with the yield variable, which is based on the daily output from April 3rd through December 27th. And I'm going to ask the computer to pick the combination of days that gives us a match to what the actual production was. You'll see I'm forcing that to not go over by having a constraint here on the maximum tons. So I'll hit the button and see what happens.
Solver is running to achieve minimum shortage tons. Solver calculations are complete.
So
All constraints are satisfied.
So you see that happen. Calculation time was 7 seconds, much better than what we were struggling with all the other stuff running on the internet. It picked this combination of days, and you see the optimization tons are precisely the same as the target. They were constrained by the maximum tons constraint. You see up here the incremental change was 0. The no difference in hours per week or variable cost. We're using the $1,800 variable cost that you indicated was appropriate for the site, and using the average from the calculations for the ton per operated hour and the percent runtime. So to look at the incremental change, we could start out again staying down in the yield area by noting that the feasibility exists for between 40 and 50% yield of 57s, which I perceive to be one of your key products. So let's just add 4% to the yield to make it 41%, and we'll just add 2% to the 8s. And you'll see that generated another 92 tons of 57s, 138 tons overall. Reduced the number of hours to achieve the target by 198. Scheduled hours, 161 hours. 5.4 hours less per week, 356,581 less dollars to achieve the same results. That's one way to make an evaluation of what potential is if you make incremental improvements. So let's go up here and look at the incremental potential from the ton per operated hour, which is compared to the 1,100 ton maximum, 857. We'll say 100. We'll add 100 tons an hour to that. You see it reduce the hours, less variable cost, and increase the number of tons of key product. We do the same thing to the reliability, make that 90%, and it makes a difference again. Now we're down 17 less hours per week if we could do that. Now practically, I'm not saying it's practical, but I'm saying that it is mathematically potential based on what we see here. So if I just run that out and run for maximum 57s.
Solver is running to achieve maximum wash dates and 57s tons. Solver calculations are complete. All constraints are satisfied.
So it all blends it in. We still show surpluses beyond what would be equivalent. And we see 47 cents a ton less, variable cost down $1 million, $1.073 million. Now that's running with constraints based on the previous year-to-date production. Now if you want to see how many 8s and 57s you could produce, we just take the constraints off of that, leave the constraints on the others, and hit run for maximum.
Solver is running to achieve maximum wash dates and 57s tons. Solver calculations are complete. All constraints are satisfied.
So what this says is theoretically, you have the capacity, the plant has the capacity to produce 1.6 million tons of 57s and 850,000 tons of washed eights, your key products and byproducts. You would be able to do that running 37.8 less hours per week than the 84.6 that you're currently logging. The variable cost goes down because your scheduled hours drops to 1,730. So the potential value is 2.5 million. Emphasizing potential, not suggesting that it's practical, but it's mathematically possible, and it's all based on your data. So just wanted you to be able to see that, give you an idea of how some of the things that we discussed previously with regard to AI and computer-assisted strategy and planning work.